Hello, Algebra 1 CP students. Hopefully you're having a great day so far. Today, I would like to introduce to you our second method for solving systems of equations, and that is by substitution. We already took a look at how to solve systems of linear equations by graphing. That's just where you graph the two lines on the coordinate plane and see where they intersect, assuming they're not parallel. This is a more algebraic approach, though one of two algebraic methods that we're going to be taking a look at, and it's solving by substitution. And to get an idea of how substitution really works, I think starting with a problem like this is a good one. Given that y is equal to 6, this problem is asking you to solve the following equation for x. 8x plus 3y is equal to 10. Do you think you can solve this problem for x? Take about 3 minutes. See if you can do this. Pause the video. On pause when you think you've got it. All right, by now I assume that you've tried it on your own. Hopefully you can solve this equation for x, but if not, I'll show you how to do it. What we would do is, since we're given that y is equal to 6, we can take that value for y and just plug it into our equation. And that would tell us here that 8x plus 3 times 6, we can just replace y with 6, is equal to 10. And that idea, that act of taking this value for y that was given and replacing it for y in the equation is what substitution is all about. To solve a system of equations by substitution, we want to take a value that's given to us and substitute it in. Sometimes we have to do a little bit of work to find that value. Most of the time, it's not just going to be a number, it's going to be an expression. But regardless, we're just going to take it, substitute it in for the other equation, and work with what we've got. So at this point, we can now say to ourselves, well, this means 8x plus 18, that's 3 times 6, is equal to 10. And this goes back to our one-step equations from before at the beginning of the year. We can subtract 18 from both sides now. We would get 8x is equal to negative 8. And after we divide both sides by 8, we would end up with the solution that x is equal to negative 1. Okay? So that is how you would substitute a value. All right? And to solve systems of equations by substitution, like I said, we want to take the value that's given to us for one of the variables. It might not be just a number, it may be an expression. Substitute it or replace it into the other and solve what's left over. All right, and I think the best way to see this is through example. I have 3 examples prepared for you today. We'll go through the 3 of them, try to explain it as much in depth as I can, and hopefully it'll make sense. There's some practice problems for you to try on your own as well on Google Classroom. I highly recommend you do so. All right, so consider a problem kind of like this. When we're trying to solve a system of equations, just like when we did by graphing, we're trying to find a value for x and a value for y that satisfies both equations at the same time. So consider something like this. If I have, first problem here, x is equal to 3y minus 1 and 7x minus 5y is equal to 9. And what I want to do is I want to solve this system of equations for both x and y. So maybe I'll put the directions right up here. Solve for x and y. I want to find the value for x and the value for y that makes that system of equations true. Well, obviously I'm not given up here a number that one of the variables is equal to, but I am given an expression that one of the variables is equal to. Instead of what makes this hard is that we're dealing with 2 equations and 2 variables at the same time. But instead of doing that, if we can somehow condense this down to be 1 equation and 1 variable, well, that would make my life a whole lot easier. And if you notice, we can accomplish that by looking at my first equation. My first equation states that x is equal to 3y minus 1. Well, if x is equal to 3y minus 1, why don't we just take that 3y minus 1 and just plop it in right there for that x. Let's substitute it for the x so that we just get 1 equation with 1 variable, just y. Then, once we solve for y, we can go back, plug in our value for y, and get what x is equal to. So because we notice here that x is equal to 3y minus 1, let's substitute this x for 3 minus 1, or 3x minus 1 rather, and get here that our equation on the bottom is really 7 times 3y minus 1, because that was the value for x that just got replaced, minus 5y is equal to 9. You see how that substitution worked out? We just replaced this 3y minus 1, which is what we said x was equal to. We replaced x with that. All right. So now this really just goes back to solving equations, which is what we did before. Once you make that substitution occur, then it's just a matter of distributing. We would do 7 times 3y, that's 21y. 7 times negative 1, minus 7, minus 5y is equal to 9. And we would just continue to solve our equation. Combine like terms. 21 minus 5 is going to be, what is that? 16y minus 7 is equal to 9. It's a lovely two-step equation here. We can add 7 to both sides, giving us that 16y is equal to 16. Dividing both sides by 16, we would get that y is equal to 1. And now, since we know that y is equal to 1, we can use either of our two equations to solve for x. Personally, I'd probably pick the top one because that was the one we set. We had x just by itself on one side of the equal sign. So I would say, let's take this value now. We got y is 1. That's sort of half of my solution. Let's take that, put it back up into this equation, and say, well, if y is 1, that means that x has to equal 3 times 1 minus 1. It's like a little puzzle. Now that we know this piece, we can fill it in, substitute it for y, and solve the whole thing. We would get here that means x has to equal 3 minus 1, or x has to equal 2. And so therefore, the solution to my system of equations would be that x is equal to 2 and y is equal to 1, which you could write as that, or you could choose to write it as an ordered pair, just like we did with graphing. You could say the solution is 2, 1, because 2 represents your x and 1 represents your y. Either way, if you want to write your solution this way or you want to write your solution this way, it's totally fine. All right, but hopefully that makes sense, how we were able to say, oh, if x is equal to 3y minus 1, we can replace the x in the other equation with that expression of 3y minus 1. That replacement process is called substitution. All right, just like up here, when it was just a single number, we replaced it with the y here. All right, so hopefully that makes sense. Now, the question that kind of stems from that is, what if we're not just given like x equals an expression or y equals an expression? What if the equations are kind of jumbled up? Well, that's no problem. We can just unscramble them to solve for one of the variables. It takes a little bit of thought to get there, but I'm confident that we can do it. Let's consider a problem kind of like this. Ready? What if I had negative 2x plus y is equal to negative 13? And I also had 2x minus 4y is equal to 4. All right, and I wanted to solve that system of equations for x and y. Well, unfortunately, unlike up here where I had just x equals something and I could say, ooh, we already have x equals an expression, let's substitute that in for x. Here, I don't really have that, but I can make that happen. And what we have to do is sort of be on the lookout for, which of these variables looks like it would be easy to get by itself? Which one of these, using a little bit of algebra, does it look like it would be easy to manipulate? And personally, I would look up here and I'd see, ooh, just regular old y. Right? Do you see that? Y by itself, coefficient of 1. I'd say, wait a minute. If I just take this top equation and add 2x to both sides, let me do it in a different color. Add 2x to both sides. Then I can say that y is equal to 2x minus 13. You see how we did that? All we did was just take this top equation, add 2x to both sides. That eliminates it from the left and moves it over to the right. And now we can say, ooh, well, if y is equal to 2x minus 13, we could take that value, that expression, and plop it in right for that y. We could substitute it, giving us that 2x minus 4 times y, but we're now not calling it y. We're going to call it 2x minus 13 is equal to 4. Again, notice how that expression just substitutes for the value of y, because y is equal to that. So we're allowed to replace or substitute y with this. Almost think of it as, hey, I came up with a new name for y. You know what my new name for y is? 2x minus 13. So everywhere I see a y in the second equation, I'm going to replace it with 2x minus 13. Okay? And something you may notice is the fact that I am using parentheses here. And I did it up here as well. I should have called attention to it up here. Because up here, I'm doing 7 times x. And so I need to make sure I take 7 and multiply it by the entire quantity of what x is. Not just by the 3y. It needs to also distribute to the negative 1. Same thing down here. I'm saying y is equal to 2x minus 13. I'm doing negative 4 times y. So it needs to be negative 4 times the entirety of what y is equal to. So that's why we're using those parentheses. And even up here, when it was a single value, I made sure to use parentheses. I always encourage you to use parentheses just to keep everything in order when substituting. All right? But now that I have that, we can say, let's work out what x is equal to, then take it, plug it back in, and solve for y. We can say that 2x, distributing here, minus 8x, negative 4 times negative 13, ooh, mental math, plus 52 is equal to 4. We should be able to solve this no problem. We can say 2x minus 8x, that's going to be negative 6x. Right? If I have 2 x's and take away 8 of them, that gives me negative 6 of them. It's a little combining like terms. Plus 52 is equal to 4. Let's get x by itself by subtracting 52 from both sides. That gives me negative 6x is equal to 4. Take away 52 is going to be negative 48. And if I now divide both sides by negative 6, we would get that x is equal to 8. And that's, again, half of the mystery solved. Now that I know that x is equal to 8, I could take that value for x, put it right back up here for this x, and that will tell me what my y is. Right? It's like we solved one of the puzzle pieces. We got what x is equal to. It's equal to 8. We can now take that 8, put it into our other equation, and say that y should equal 2 times 8 minus 13, because x was 8. We're just substituting. 2 times 8 is 16, so we say y is equal to 16 minus 13, and 16 minus 13 is 3. So the solution to our system of equations is that x is equal to 8 and y is equal to 3. And by the way, you could write that as an ordered pair as well if you wanted to. Either way is totally fine. Whether you write this or you write this, either way is fine. Okay? Hopefully that makes sense. We have one more example left to do. Before I do, I just want to mention quickly that just like with graphing, how you can check your work by plugging in the value for x, plugging in the value for y, and seeing if it makes both equations true, you can absolutely do the same thing with substitution. So to check your work, you could say, well, let's find out. X is equal to 2 and y is equal to 1. Does that make both equations true? Let's see. If x is 2 and y is 1, is it true that 2 is equal to 3 times 1 minus 1? I think so. 3 times 1 is 3, minus 1 is 2, so that works. If x is 2 and y is 1, is it true that 7 times 2 minus 5 times 1 is equal to 9? I think that's true as well. 7 times 2 is 14, minus 5 is equal to 9. So that's a quick way that you could take an extra 30 seconds, go back, substitute, and check your work. And if you find that it doesn't work out, then that's a good indication that you may have made a mistake. So just keep that in mind. Let's do the same with the bottom one here. I could say, oh, x is 8 and y is 3. Well, that means it must be true that negative 2 times 8 plus 3 should equal negative 13, which it does. Negative 2 times 8 is negative 16, plus 3 is equal to negative 13. And it must be true that 2 times 8 minus 4 times 3 is equal to 4. Well, 2 times 8 is 16, minus 4 times 3, which is 12. 16 minus 12 does, in fact, equal 4. So that works as well. All right, so taking that extra little bit to check your work is a great way to ensure that you're not making mistakes. Hopefully no questions on that. We're going to go on to the next one and the last one of the day. Ready? How about something like this? If I have 2x plus 4y is equal to 20, and I also have 6x minus 7y is equal to negative 16. And I'm trying to solve that system of equations. Again, there's not like a clear starting point like in the last one where it's not just, oh, y equals 6. X equals something right away. Ooh, only one step to get y by itself. Here, notice there's no coefficient of 1, so it's going to take a few steps to get one of the variables by itself, which I need to do first. However, we should look at these two equations and say, which one is going to be easier to work with? And the one that's going to be easier to work with by far is the top one. Do you notice that if I tried to move terms around and get, say, x by itself in the bottom one or y by itself, that's going to involve some fractions because say we wanted to get y by itself. I'd subtract 6x from both sides. Then I'd have to divide by negative 7. 6 divided by 7, 16 divided by 7, those are both going to be decimal answers, right? I'd rather not work with that if I can help it. I'd much rather instead work with the top equation. Notice all even numbers, 2 and 4 both go into 20. So a good indication as to where to start is to recognize, ooh, this is probably going to result in integers versus fractions. And let's, if we can, divide by the lowest coefficient to avoid any fractions if possible. So I would probably identify here, ooh, it would be good to get x by itself. In order to do that, we can subtract 4y over to the other side. If I do minus 4y and minus 4y, we would get 2x is equal to negative 4y plus 20. Or you could write that as 20 minus 4y if you wanted to. And now that almost has x by itself. We're almost allowed to substitute. But one thing left to do is just to get x alone, we can divide everything by 2. And once we divide the whole equation by 2, we get x is equal to negative 2y and then plus 20 divided by 2 plus 10. So now that we know that x is equal to negative 2y plus 10, we've now come up with a new name for x. We can call x negative 2y plus 10. And now we can take this negative 2y plus 10 and substitute it in for this x right over here. We could say, well, if I know that x is now equal to this, let's put it into our second equation, the one that we did not yet work with. And we can say, well, 6 times x, which we now know is negative 2y plus 10, minus 7y should equal negative 16. See how that substitution works? Once we're able to get x by itself, we can put it in for the variable into the second equation that we did not work with yet. Okay. Notice if you put it back in the equation you already worked with, you're going to end up with just everything kind of canceling out. That's not going to help you very much. You put it into the equation that you have not manipulated yet. Once you do that, you can now go ahead and solve for y. And then once we have our value for y, put it back up here and solve for x. Ready? I would distribute the 6 everywhere. I would get negative 12y plus 60, 6 times 10, minus 7y is equal to negative 16. Combining like terms here, negative 12y minus 7y is going to be negative 19y plus 60 is equal to negative 16. To get y by itself, we can subtract 60 on both sides. We would get negative 19y is equal to negative 76. And then a little bit of mental math here, dividing both sides by negative 19. We would get that y is equal to 4. negative 76 divided by negative 19. And now that we know that y is equal to 4, we can take this value for y, half of the puzzle that we've solved, put it right back up here because this will tell us what x is. And we can say to ourselves now, well, x is equal to negative 2 times y, but we now know y is 4, plus 10. Meaning that x has to equal negative 8 plus 10, or in other words, x is 2. So the solution to our system of equations is x is equal to 2 and y is equal to 4. Or you could write it as an ordered pair, 2 comma 4. Again, notice if I went back and substituted, we could check our work to say, ooh, is it true that if x is 2 and y is 4, this works out? Well, 2 times 2 plus 4 times 4 does equal 20. And 6 times 2 minus 7 times 4 does equal negative 16. That's going to be 12 minus 28, which equals negative 16. All right? So, just a quick little recap. That's exactly how you solve systems of equations by substitution. It really goes back to this idea with the little do now. If you're just given a value for y, you would put it in to find out what the value for x is equal to, right? So that's exactly what we're doing, except we're not just given singular numbers, we're given expressions. And so we can take this value for x, this expression, plug it in to replace this x, and solve for y. Once we have that, we could take that, put it back up here, and figure out x. If we need to do a little bit of work to make that happen, no problem. We can do a little bit of algebra to say, hey, I can manipulate this top equation to get y alone, or one of the variables alone. And then once I do that, take that equation, substitute it, and solve. And in a situation where it's maybe not so obvious which one to start with, or what would be the easiest to start with, think of how you could avoid fractions and decimals. And that's definitely what I recommend. Here, notice the bottom equation would give me some pretty horrible decimals if we tried to get x or y by itself at the start of that problem. But the top equation being all even numbers and all multiples of each other, that's a good one where we could say, hey, that's probably a good place to start. So once we get x or y by itself, we substitute for the other variable in the other equation, solve for whatever variable we're looking for, in this case y, and then take that value and solve for x. It's like a little puzzle. All right? So hopefully that made sense. Tomorrow, there will be another video, or you may be with me in class. But regardless, we will be exploring more examples on this. We'll probably do about 4 more of them tomorrow. You'll have the rest of the week to practice on solving by substitution as well. It's a super important skill. It gets used all throughout your mathematics career. Geometry, Algebra 2, pre-calculus, calculus. You solve by substitution all the time. So it's very important to understand the idea. All right? Thank you so much for your attention and focus today. Again, I encourage you to try the practice problems on Google Classroom. Best of luck. If you need anything, don't hesitate to reach out. Have a great rest of your day, everyone. Take care.